Good day, students. So for today, we're going to discuss about the forms of energy and the work and the power. But for now, we're going to focus on the different forms of energy such as the potential energy and then the kinetic energy. With potential energy. A body may require potential energy on account of its composition, position, or state of strain. So a potential energy, it talks about the energy stored and conserved due to its position relative to some zero position. So it also talks about the energy that has the potential to do work. Parang ito yung tumutukoy dun sa mga object or dun sa body which is at rest. Okay? Kumbaga, at rest bago pa lang siya mag-move. Okay? So, we have here an example. So, a yo-yo before it is being released. Ibig sabihin, yung potential energy doon is naka-store dun sa mismong yo-yo before pa siya ma-release. Okay? And then next is the water behind the dam. Okay? So, ibig sabihin, naka-store yung water. Okay? Hindi pa siya yung nag-move. It is behind the dam. So, ayun nga, we have these bodies like bullet, gasoline, firecrackers, bombs, and coal. They possess potential energy on account of their composition. Okay, or yung structure nila. So, bodies that are elevated like a ball on top of a cabinet, a rock about to fall from a cliff, a coconut about to fall are examples for potential energy based from position. Okay, so this tackles about the bodies that are elevated or yung kumbaga nasa taas. Okay? Yun sa binigay ko example kanina about dun sa water behind the dam. So, pwede rin siya maging example nung potential energy based from its position. Kasi, it is stored behind the dam and it is about to flow pa lang. Okay? Potential energy. So, bodies like a compressed spring, a stretch spring, a slingshot about to release, a bow and arrow ready to be shot, and a compressed gas refers to the state of strain of a potential energy. So, when we talk about strain, so it refers to the deformation produced on a body by a force called stress. Kumbaga, dun sa strain, it is the change or yung na-deform na yung mismong body or yung mismong object natin because of this force na tinatawag naman nating stress. Okay? Next, we have here, the amount of potential energy depends on the weight of the body and the height of the elevation. So, it is equal to the amount of work that a body can perform. So, we have here the given formula for potential energy, which is equal to the weight and the height. So, we're just going to get its product. Alright? So, kung mapapansin nyo dun sa mga word problem natin dyan, so, meron tayong given weight and the height. So, the weight of an object is defined as the force of gravity on the object and may be calculated as the mass times the acceleration of gravity. So, we have here the W is equal to mg. So, yung m po dyan, it represents the mass, and then yung g, ito yung nagre-represent para dun sa acceleration natin due to gravity. So, kumbaga, for example niyan is yung object is nasa taas ng cliff and it is being released or nahulog yung isang object. So, doon natin masasubstitute yung value ng acceleration due to gravity. Okay? And since the weight is a force, its SI unit is the Newton. So, same lang sila ng force at saka ng weight na Newton po ang magiging SI unit natin. So, please take note, ito yung mga given units natin at saka yung value ng acceleration due to gravity natin. So, when the unit of the mass is in grams, therefore, the acceleration due to gravity natin in is in centimeter, or it is equal to 980 centimeters per second per second. Ibig sabihin nun is 980 centimeters per or slash s squared. Okay? And in terms of kilograms, ang acceleration naman niya is equal to 9.8 meters per second per second. And when it is in slug, yung mass natin, so the equivalent acceleration due to gravity is equal to 32 feet per second per second. Okay? And we have here this given word problem. A rock weighing 500 newtons is about to fall from a cliff 60 meters high. Find the amount of potential energy possessed by the rock on account of its position. So in here, given po yung weight ng mismong object natin. Ano yung object? Yung rock. Okay? So 500 newtons yung kanyang weight. And it is about to fall pa lamang. Ibig sabihin, hindi pa siya nare-release from the cliff. So yung height is equal to 60 meters. So therefore, ang gagamitin po nating formula is yung potential energy is equal to weight times height. Alright? And then next, we're just going to substitute the given values. So for the weight, since it is equal to force, so 500 Newton. So the Newton will be the unit na gagamitin natin. And ano ulit yung height? So we have here 60 meters. And then, kasasabi ko lang kanina, we're just going to get the product. So 500 times 60, we have 30,000. And what will be the unit for the final answer? So when we're going to find the product, pasasamahin lang natin yung unit ng dalawang values. Okay? So we have here Newton times meter. Okay? Or isimplify natin, yung equivalent ng unit na yon, yung Newton and meter, is equal to joules since we're talking about energy. So joules po yung kanyang unit. Alright? So in this given word problem, the final answer is 30,000 Newton meter or 30,000 joules. Next example. A 600 kilogram pile driver was released from a height of 8 meters. Find the amount of potential energy possessed by the pile driver before it was released. So in here, meron tayong given mass. Okay? Hindi weight yung given sa atin dito, kundi mass. So ano yung mass daw natin ng pile driver? So we have here 600 kilograms. And it was released from a height of 8 meters. Okay? So dito pa lang, mapapansin na ninyo na iba yung given na unit natin. Okay? So dito, ang gagawin natin, since yung ating weight is equal lang din naman siya, or it's equivalent to the product of the mass and the acceleration due to gravity, so yun yung gagamitin natin na formula. And then, ito multiply lang natin siya sa height. Okay? So, kung mapapansin nyo dito, ang ginamit nating formula is potential energy or PE is equal to mgh. Yung mg dito is equivalent lang siya nung weight na ginamit natin dun sa unang example. So, I hope you understand it. And then, ayun nga, so since a pile driver was released from a height of 8 meters and then the given unit for the mass is in kilograms, therefore, ang gagamitin nating acceleration due to gravity is in meter per second squared. Ibig sabihin, 9.8 yung magiging value ng acceleration natin. Okay? And then, substitute lang natin yung given values. For the mass, we have 600 kilograms. And yun nga, yung G natin dito, yung acceleration due to gravity is 9.8 meter per second squared. And then yung height, okay, is 8 meters. Again, we're just going to find the product of these values. So 600 times 9.8 times 8, it is equal to 47,040 Newton meter or 47,040 joules. So, ang nangyari dito, kung mapapansin nyo, sa mga nakarang example ko sa inyo, di ba, since we are looking for the force, di ba, ang Newton is, yung unit nating Newton is a combination of 3 units. So, we have there the kilograms, the meter, and then the seconds or the S squared. Okay? So, dito, yung kilogram, meter per second squared, so, yun po yung naging unit natin na Newton. Okay? Kung tandaan nyo po yung diniscuss ko nung nakaraan. And then, minultiply lang natin siya ulit dun sa isa pang meter. Okay? Kaya naging N times M yung ating unit dun sa final answer. Okay? So, ulitin ko, yung mg po dyan is equivalent lang siya dun sa weight. Kaya Newton pa rin yung kanyang unit. Alright? So, we're through with potential energy and we will move the next form of energy, which is the kinetic energy. So, ito, basta mapansin ninyo that an object is moving, therefore, it has or it possesses kinetic energy. Okay? So, kinetic energy is energy in motion. So, it is possessed by moving bodies. So, sinabi ko nga kanina. So, basta kung mapapansin ninyo na that an object is moving, it possesses kinetic energy. Alright? And we have here the given formula for kinetic energy, which is equal to 1/2 mv squared. So, kinetic energy is directly proportional to the mass of an object or a body and to the square of its velocity. Meaning to say, kapag dumaan kayo dun sa word problem natin and there is a given velocity, you're going to get its square. Alright? Next, if the mass has units of kilograms and the velocity of meters per second, the kinetic energy has units of kilograms meters per meter squared per second squared. So, the kinetic energy is usually measured in units of joules. So, sabi ko nga sa inyo kanina, yung energy, it has a unit of joules. Alright? So, 1 joule is equal to 1 Newton meter or it is equal yung, kumbaga, long type ng ating unit. So, it is equal to 1 kilogram times meter squared per second squared. So, pakitandaan po niyan. So, we have here the given word problem. A car with a mass of 1,200 kilograms is running at a velocity of 15 meters per second. Find the kinetic energy it possesses. So, we have here the given. So, yung mass natin dyan is in kilogram and the value is equal to 1,200. And the velocity, we have 15 meter per second. So, pakitandaan po na kapag velocity yung usapan natin, therefore, yung unit natin is in meter per second. So, the formula that we're going to use is yung pinresent natin kanina. So, we have here the 1/2 mv squared. And then, we're just going to substitute lang po yung values. So, for the mass, we have 1,200 kilograms. And for the velocity, we have 15 meter per second. And again, di ba sabi ko sa inyo kanina, hahanapin natin yung square niya. So, just copy para dun sa third part ng solution natin. Copy lang natin yung 1/2 and then yung 1,200 in mass. And the square of 15 meter per second is equal to 225 meter squared s squared. So, hindi lang yung mismong value yung kinukuha na natin ng square, but yung units din. Okay? Kaya ganito yung naging result ng ating units. So, naging m squared per second squared siya. Next is, we're going to multiply the numerator or yung 1 dun sa 1/2 natin, dun sa values natin ng mass at saka ng velocity. So we have here 1 times 1,200 kilograms times 225 meters squared per s squared. So it is divided by 2. So ito yung solution natin, 270,000 kilograms m squared s squared per s squared. Okay? So paki-correct na lang po niyan. So dapat yan is m squared per s squared divided by 2. So we have here the final answer, which is equal to 135,000 kilograms m squared per s squared. Okay? So, yung ating final answer, so pwede nyo rin siyang i-present in scientific notation. So, ayan. So, naka-scientific notation yung ating final answer dyan. So, itinuro ko na rin naman sa inyo yung rule kung paano tayo magko-convert nung mismong naka-whole number siya into scientific notation. So, this one, so 135,000, so ilang digits ba ang meron tayo dyan? So, di ba, 6. Okay? So, ipagpalagay natin na may point dun sa last part. Okay? Okay. So, ang gagawin natin is mag-move tayo to the left nung point natin. Okay? So, ang gagawin ninyo is 1 dun sa isang 0, 2, 3, 4, 5. Okay? So, kasi, di ba, ang rule natin is bawal mag-exceed sa 10 yung ating whole number. Okay? So, dito, since nag-move tayo ng 5 to the left, ibig sabihin, yung 5 yung magiging exponent ng ating times 10 dyan. And since nag-move tayo to the left, ibig sabihin, magiging positive yung value ng exponent natin. Kaya dun sa final answer natin, since 2 digits din naman yung kinukuha natin after the decimal point, so we have the final answer which is equal to 1.35 times 10 raised to 5. And ano po ulit yung unit? So we have here the kilograms, meter squared per second squared, or it is equal to joules. Next is the calculation of work. So this is just another topic. So the work is the product of the force and then the distance. So it is calculated as the work equals force times distance. Here, these two situation wherein ipapakita that an object has no work. So first is when a force acts on a body and it does not move the body through any distance, then there is no distance covered and there is no work accomplished. And then the second situation, when a distance is given and no force is acting, no work is possible. Ibig sabihin, kahit dun sa una, kahit mag-alat ka pa ng force dyan, kahit gano'n pa katindi yung force na in-exert mo dun sa isang body or dun sa isang object, but hindi naman niya na-cover yung given distance, therefore, wala ring work na naganap. Okay? And then dun sa second naman, so, kapag given lang yung distance and hindi ka naman pala nag-exert ng force, yon, so there is no force acting upon the object, so therefore, wala ring force na nangyari. Okay? Nawala ring work na nangyari, sorry. Next, here are the work units under the three systems of measurement. So we have here the CGS, MKS, and FPS. So, since we are looking for the work, so meron tayong mga underlying units under ng force at saka ng distance. So kapag ka CGS yung units, so yung force natin dyan is equal to dynes. And then for the distance, we have centimeter. And sa final answer natin, ito yung magiging unit natin. 9 centimeter or it is equal to ergs. Okay? And then kapag ka MKS yung unit yung unit natin, so under ng force, we have Newton. And kapag ka distance, we have meter. So, the final answer, ang magiging unit natin is Newton, meters, or joules. Ito yung kalimitan nating binibigay sa mga word problem. Okay, ito yung mga normal na, kumbaga, units. Okay, yung usual na binibigay na units sa mga word problem. Kasi kung in CGS siya, and then yung sunod, yung FPS, minsan kasi, kapag hinanap pa yung, kapag ka, binigyan kayo ng task na kailangan nyo pa siyang i-convert into MKS. So, ayun. So, panibagong solution na naman yung magagawa ninyo. Ano po? So, kaya, ang usual na binibigay sa mga word problem is in Newton, meter, yung ating value or yung unit. Okay? And then, dun sa FPS, dun sa force, we have pounds. And then, sa distance, we have feet. And then, kapag pinag-combine natin siya, and nakabuo tayo ng work, we have here the given unit, which is equal to foot, pound, or feet, pound. So, an example word problem, a force of 540 Newton is needed to move a body through a distance of 20 meters. How much work is accomplished? So, meron tayo diyang given na force, which is equal to 540 Newton, and meron tayong na given na distance, which is equal to 20 meters. So, ang tinatanong natin dito is yung force. So, again, yung ating gagamiting formula is yung force times distance. And the next is, magsasubstitute lang tayo ng values. So, for the force, we have 540 newtons, and the distance, we have 20 meters. So, the total amount of work being accomplished is equal to 10,800 Newton meter, or in scientific notation, we have here the 1.08 times 10 raised to 4 Newton meter, or joules yung shortcut na unit natin. Okay, again, yung joules is a combination of the units ng Newton at saka ng meter. Lastly, we have this calculation of power. So, it is scientifically interpreted as the rate of doing work. It answers the question, how fast is the work accomplished? And this requires work units and time units. So, it is represented as power is equal to work over time. Okay? So, para dun sa simpleng formula natin, we have here this representation for the power as P, and then dun sa work is W, and para dun sa time, we have T. Next, so, meron tayo itong given word problem. A tired squirrel, mass of approximately 1 kilogram, does push-ups by applying a force to elevate its center of mass by 5 centimeter in order to do a mere 0.50 joule of work. If the tired squirrel does all this work in 2 seconds, then determine its power. So in this given word problem, we have the value of work, which is equal to 0.50 joules. Okay? Or J na lang para dun sa unit natin. And then, yung time natin is 2 seconds. And for the solution, the power rating of this squirrel is found by power is equal to work over time. And then, substitute lang natin yung given values. So, 0.50 joules divided by 2 seconds. So, for the final answer, divide lang natin yon, we got 0.25 joules per second. Okay? Or, yung simplest unit natin, pag pinag-combine natin yung dalawang units na yun, so we have here the watts. Lastly, when doing a chin-up, a physics student lifts her 42.0 kilogram body a distance of 0.25 meters in 2 seconds. What is the power delivered by the student's biceps? So for this word problem, we have here the given mass, which is equal to 42.0 kilograms. Distance equals 0.25 meters. And for the time, we have here 2 seconds. And again, we're looking for the power. So in the solution, di ba kung mapapansin nyo, napakadami nung steps niya. Okay? Kasi kailangan natin kuhanin yung mismong value ng ating work. Okay? Since dito sa word problem natin, ang mga given lang is yung mass, distance, and time. Kaya napakaraming process niya bago mo pa makuha yung kanyang work. Okay? So dito, so for the first solution, kailangan natin kuhanin yung amount ng force. Okay? So, the student must apply a force which is equal to her weight. So, yun nga. So, we have here this 42 kilograms, yun yung bigat nung student, physics student, and imumultiply natin siya sa 9.8 meter per second squared. Okay? Since kasi yung kanyang mass is in kilograms, kaya yung acceleration niya due to gravity is 9.8 meter per second squared. Okay? And then, ang force natin is equal to 411.16 kilogram meter per second squared, or simply Newton. Okay? So, para naman makuha natin yung work, so since dun sa unang solution nakuha natin yung force, pwede na nating i-substitute yung nakuha nating answer para dun sa force. Since we have here the given formula for work, which is force times distance. Again, substitution lang tayo ng values. So, dun sa work, dun sa force, we have 411.6 Newton multiplied by the distance covered. So, we have 0.25 meter. Okay? And then, when we get the product, we have here the answer, which is equal to 102.9 joules. So, paano po nangyari ulit yung joules? Kasi, pinag-combine lang natin yung unit natin na Newton at saka yung mass. Okay? And then, since nakuha na natin yung given or yung work, okay, to lift her body, so ngayon, pwede na nating ma-compute yung mismong power. Okay? So, since the power is to work over time ratio, so it is represented by the given formula, P is equal to W over T. And then, substitute lang natin yung nakuha nating value para dun sa work. So, we have 102.9 joules. And dun sa time, given na naman po siya dun sa mismong word problem natin. So, it is equal to 2 seconds. And get the quotient. So, we have 102.9 divided by 2, we will get 51.45. Okay? And then, don't forget to include the units. Okay? So, since nag-divide tayo dito, therefore, yung magiging unit natin is joule per second. Okay? So, yung kanina, so, yung simplified natin na unit sa power is equal to watts. So, meron na naman pong naka-include na conversion yan sa inyong pamphlet kapag mismong horsepower na yung hinahanap natin. Ano po? So,